Hello, class. Welcome back. Today we're going to go ahead and continue chapter 8. Right now we just started section 8.3. Right, the t-test for a mean. This is going to be in page 434. And right, when do we know? Right, one question that was being asked is, hey, how can I differentiate section 8.2 and section 8.3? Specifically, for section 8.3, you'll notice that the population standard deviation is not given to you. All right. So when you notice that it is not given to you, right, you would go ahead and apply the t-test, right, which is what we're about to go ahead and do today. Right, we're going to go ahead and do approximately 4 examples, all right, to the different type of scenarios, but it's still going to be, right, the formula is going to be a little bit different. I'm sorry, it's going to be the same, just different variables. The table we're going to be using is going to be different, right? But the same process and scenario, drawing, sketching the bell curve, and finding your critical values and your observed values, right? Do you reject the null hypothesis or do you fail to reject it, right? Please have this table handy, right, for your exam. Table F, the t-distribution table. Okay. For your test questions, right, another question that was being asked is, hey, when do I know, right? It's kind of, how do I say this? You know which test to do, whether you're doing a one-tailed test or a two-tailed test based on your alternate hypotheses, right? What we went over in section 8.2. But you're in the test, you're also going to give you some problems where I tell you straight off, right? Hey, giving this alpha value, do a one-tailed test or a two-tailed test, right? So half of them would be, you're going to get some of them where it's where I tell you which test to run. All right. So let's go ahead and get started, right? The formula we're going to go ahead and be using, all right. Right, we have our t crit, right? Our t critical value. This pen isn't working. There you go. T crit is going to be degrees of freedom minus 1. So to find T crit, your degrees of freedom is going to be n minus 1 at alpha equals blank for a that's right. So to find your t crit, it is going to be the degrees of freedom, and moving forward, right, the degrees of freedom is going to be your sample size minus 1. All right. It's going to be your sample size minus 1. All right. My t observed, all right, the value you're going to go ahead and be observing, mean minus your mu over, very nice, all right, your sample standard deviation over the square root of n, all right, where we said the standard error, right, is that right there. Okay, so these are the main ones we're going to be using, right? And we're going to see how do we apply t-crit, all right? Because I think that's where you might be stating, hey, what is going on, right? So reading the question, right, we find out that, right, I need to go ahead and determine my alternate hypotheses, all right? So zoom in a little bit here. Let's go ahead and do A, right? We'll find my alternate hypothesis. And we found that the cigarette smokers on average smokes on average 29 cigs a day. She feels that this average is too low. All right. She selected a random sample of smokers, that they right some percentage deviation to that. Is there enough evidence to support a claim, right, that the average is too low? So if my average is too low, right, my alternate hypotheses will then have to be it's greater than that, right? I'm looking for anything greater than that, meaning my null hypotheses, right, would be 29, right? For B, find your critical value, all right? Let's go ahead and find t-crit. How I find t-crit is degrees of freedom is equal to, you know what, I'm sorry, let's go ahead and write everything out, right? Let's go ahead and write out what were the knowns and the givens, right? My mean, right, find my mu, my sample standard deviation, and my n, right? Say we also want to find our alpha, all right? So let's go ahead and find my mean, that is mean number of 31, all right? Very, very nice. I know that my mu, right, it's part of this, right? That's going to be 29. My sample stand dev is 2.5. My sample size, what is my sample size? It's like the random sample of 10 smokers, right? That's 10, and the alpha was given is 0.10. Right? So I have that. Right, so t-crit is going to be the degrees of freedom is equal to n minus 1. So this is going to be 10 minus 1, which is 9, right? It's going to be 9. And going real quick to A, it's to greater than, so I know it's going to be a one-told test, right? So I know that going in. So degrees of freedom is 10 n minus 1, which is 10 minus 1, which is equal to 9. At alpha equals 0.10 for a one-told test. And I know it's a one-told test based on my alternate hypotheses, right? It's greater than, right? For greater than statement. So this here is what's going to be useful. The degrees of freedom equals 9 at alpha at 0.10 for a one-told test, right? So you're going to go ahead and pull up your t-table, right? Why is this in the way? Right, we're going to go ahead and pull up our t-table. Oops, sorry about that. There we go. We're going to go ahead and pull up our t-table. What was I saying? Okay, degrees of freedom of 9 at alpha 0.10 for a one-told test. All right. So right here, your degrees of freedom on your left, right? And we're going to go to 9. Right here, I'm going to be looking at this row. All right. The row number 9. All right. It is for a one-told test. All right, a one-told test for an alpha of 0.10. All right, right there, 0.10. So I'm going to go all the way down until I hit 9. And I see here, all right, what do we get? There we go, 1.383, all right? Because this is crossed with degrees of freedom equals 9, and it's crossed with a one-told test at alpha equals 0.10. All right, so that is the value you're looking for, 1.383, 1.383. So my t-crit is positive 1.383, right? It's going to be positive because it's to the right, right? On the right, it's a right tail, but if it was to the left, it would be negative. And if it was a two-tail test, it'll be plus or minus, right? So let's go ahead and draw that bell curve. So I have something like this. And yes, you do have to go ahead and draw this on the exam. Right, I have here z is equal to 1.383. That is the value. And let's go ahead and observe it, right? Let's go ahead and be observed, all right? Get the z out of there, excuse me. T observed is, right, x bar minus mu over error, right? Which here would give me 31 minus 29 over 2.5 over square root of 10. And we said we want to be very careful with these parentheses, right? Let's go ahead and plug into our calculator. So what do we get? I get 2.530, right? 2.530. Right, and just like before, right, you're gonna make an observation, right? Is that value, all right, is that value inside the critical region or not? Yeah, it is, right? It's to the right of that. All right, so, all right, it is to the right of it. So yes, it's in the critical region, therefore reject null hypotheses, right? We're still using that method from before, all right? All right, we're still using that method from before. All right, meaning you want to go ahead and answer yes to your question. All right, what was the question? Is there evidence to support? Right, there's my question. It's what's second to last. You would write for your answer. You would write, yes, there is enough evidence to support her claim, right, that the average is too low. All right. You know, I'll go ahead and take that. All right. So, very, very nice. Let's go ahead and do another case, right? We got problem with sleep time. Very, very nice. With sleep time. So let's go ahead and write out what's given, right? Okay, very, very, very nice. A person reads the average number of hours an adult sleeps. A person read that the average number of hours an adult sleeps on Friday night to Saturday morning was 7.3 hours, right? 7.3 hours. So 3 hours. A researcher feels that college students do not sleep 7.3 hours on average. Oh, so right here, right off the back, I already know what my alternate hypothesis is, right? With my null hypotheses, then. Nice, right? There's a difference in the wording there, right? Just like before. The researcher randomly selected 17 students. That is my n. And you may even want to write degrees of freedom down here if you want it as well, right? Which is n minus 1, which is 17 minus 1, which is 16. Right? You have everything handy. And found that the average they slept was 8.5, right? So the average they slept was 8.5, right? That is my focus point. All right. My mean, the standard deviation of the sample is all right? Not of the population, of the sample is 1.4. At alpha equals 0.01. Is there enough evidence to say that the college students did not sleep 7.3 hours on average? All right. Awesome. So let's go ahead and get started. We already have our data written out, right? Next step would be to find t-crit. Right. And we know, right, that this is going to be what? A two-tailed test, right? Two-tailed test. So my t-crit is the degrees of freedom equals n minus 1, which ends up being 16 at alpha equals 0.01 for a two-tailed test. Right. Again, right, you want to read the question completely, right? You can tell from the hypothesis statement if you're going to have one-tailed test or two-tailed test. And remember, for the test, there's going to be some questions. Well, I'll tell you, right? You're still going to have to go ahead and give me the hypotheses, right? But if you realize, if I tell you which test to make, then that should cancel out any confusion, all right? All right. So for a two-tailed test, right? So meaning you're going to go ahead and get your t-table, right? Right, and we're looking for a two-tailed test at 0.01, right, for 16. All right, so two-tailed test at 0.01, go all the way down until we cross it with 16, right?
2.291. Is it 16? Yeah, 16. All right, 2.921, 2.921. So this is plus or minus 2.921. All right, 2.921. Let's go ahead and get this out of the way. All right, so it gives me this, meaning, go ahead and draw that. All right, so this is going to be negative 2.921. It is going to be positive 2.921. And again, right, meaning the middle would be 0. Okay, very, very, very nice. Okay, let's go ahead and find observe, right? The observed, my observed value, my test value. All right. Right, we plug everything in. All right. We plug everything in. What do we get? We should get 3.534, right? And an emphasis again, whenever you're doing a two-tailed test, please be sure to write plus or minus for both of them, all right? Don't let that be a little slip up, right? To give you as many points as possible. Right, so you're going to go ahead and make that observation, right? Is it in the positive 3.534? Yeah, definitely, right? It's on this end, and it's definitely there. Yay. All right, so yes. All right. No hypotheses. All right. All right, so if you're going to answer yes, if you're going to answer to the question, right? The question was, is there enough evidence to say that these students did not sleep? Yeah, you would say yes, there is enough evidence to say that the college students do not sleep 7.3 hours on average, right? Very, very, very nice. Very, very, very nice. Okay, let's go ahead and start with another problem. A little bit bigger. There you go. Right. Right, a US web uses snapshot indicated a monthly average of 36 internet visits of a particular website per user from home, a random sample of 24. All right, so let's go ahead and see. So my mu is going to be 36. A random sample of 24 internet users yielded a sample mean of 37.9. All right, again, you're doing S and not sigma, right? Because it's the oh no, wait, that's my bad. It's a sample mean, right? Sample mean, this should be 37.9 with a standard deviation of 5.3. Ah, you see, but it's still there, right? We're dealing with samples here. So this one's still worded a little bit differently, right? It's referring to the sample standard deviation, all right? So again, right, it's not population mean or with a population standard deviation. So please be careful, right? So this is going to be, what was I saying? Sample, yes, sample standard dev, which is a 5.3. Nice. Can it be concluded that this differs from the national average? All right. So in other words, it's a right for my null hypotheses. All right. My mu has to be 36. And if it's something different, right? If it's something different, right? It's going to be less. It's going to be well, it's going to be less. It's going to be more. Then it's going to be not it, right? So in other words, it's just I just want to know if it's completely different, right? If it's not 36, all right. Yes, right. This is a two-tailed test again, right? A two-tailed test, meaning your t crit, right? Your critical value should be 2 of them, right? Your degrees of freedom, right? Whoa, I'm so sorry about this. Your degrees of freedom goes up there. All right, that should go up there. What am I doing? All right, your alpha was, I saw it, 0.05. your degrees of freedom was 24 minus 1, which is 23, right? Okay, let's go find it. Go ahead and find t-crit. Right, so this, we know this is degrees of freedom of n minus 1, which gave me 23 at alpha equals 0.05 for a two-tailed test, right? For a two-tailed test. So let's go ahead and find that, right? Let's go ahead and find that. 23.052. 23.052. So 20. All right, so 23 is going to be that last row. I know it was a two-tailed test, right, for a 0.05, right here, 0.05 two-tailed test. I should get 2.069, right? 2.069. Very, very, very nice. 2.069. So I know this is a two-tailed test, so this is going to be plus or minus 2.069, right? So let's go ahead and draw that. This is negative 2.069, 2.069. All right, let's go ahead and find t observed. T observed, right? Go ahead and plug all those in, right? Plug in all those values in to just computational problem. You should get 1.756, right? Again, the main point, right? Whenever I'm grading these, the main part ends up being people forget the, right? Everything is correct, right? It's just these parts here. So please be careful. Please make sure you wrap that in parentheses. Where this here is a 0. And 1.756, that's actually to the left of that, right? So no, it is not in the critical region, all right? So you say no, fail to reject hypotheses, right? Or do not reject no hypotheses, right? So that means you're going to answer no to the question. So no, right, the question is up here. All right, from there. So no, it cannot be concluded that this differs from the national average, all right? Very, very, very nice. Okay. And last but not least, all right? What do we have here? 8.3.16, right? Gonna make that a little bit bigger. All right. So a random sample of stipends of teaching assistants in economics listed. Is there sufficient evidence at a given alpha level to conclude that the average stipend differs from 15,500? All right. So it is not 15,500, right? So, right, automatically, I already know what my mu is, all right? So let's go ahead and I'm going to find my X bar, all right? We're going to have to find my mu, which I found. And this mu, right, I won't have you, if I give you, I'm going to give you a problem like this on the exam, your mu is always going to be given to you, right? That's one thing you're not going to have to compute. One thing you are going to have to compute is your X bar, your sample standard deviation, right? And right, we know how to get our n, right? Your alpha is also going to be given to you, and you know how to find the freedom, right? Right. So, pre-work, right? This one definitely has pre-work, right? So actually, let's go ahead and move some of these things around, right? Let's go ahead and move this here. I'm going to have to block this off like that, all right? So one thing that I want to go ahead and find first is I'm going to list all these values out, all right? So usually what I like to write is X and give myself a column, right, of just these X values. This is 13,185, right? And I'll be right back. There we go. I've listed all my X values, right? I've gone ahead and listed them vertically. Oh, you might be saying, hey, I need you to remember this, this formula here. Your variance is equal to your sum of squares over n minus 1. You are going to have to be using this formula in the exam, all right? For example, right, I'll go ahead and find as an example after this, right, where I give you the sum of squares, right, but the only thing you are missing, right, I give you everything, I give you X bar, I give you everything, but the only thing you're missing, right, is going to be the standard deviation, right? So I'll be giving you the sum of squares. You know how to find the degrees of freedom, meaning you're going to have to plug this formula in to find your variance. Once you find your variance, you know you can just take the square root of it to find your standard deviation, right? So this important formula is very, very, very important, right? You're going to get probably 1 or 2, maybe even 3 of these where you have to work it out completely. Learn how to do it by hand. If you're confident you can do this by hand, like very easily, yeah, you can go ahead and then just send your data to Excel, all right, if you're really, really confident. But you are, right, remember, Excel isn't allowed in during the exam, so you're going to have to show all your work, right? One thing I want to go ahead and find now is I know X bar is equal to the sum of my X values over N, all right? And that is going to be adding all these up, right? Adding all these up, and let's see what we get. Right, I got 154,562 divided by N, all right? All right, divided by N, which is, the N value, right, is 1, 2, 3, 4, 5, that's 10, that's 11, all right? And my degrees of freedom is 10. Divided by 11, meaning my X bar, right, my mean is just 14,051.1, all right? And of course, right, one thing you may want to have is have send your data to Excel, and as you're working this by hand, right, have Excel on the side already. You already know how to use the code for standard deviation and variance and mean, right? So find out, right, and be like, okay, I did it right? I need to make sure I have these skills polished up. I want you to at least do that, right? Take it step by step, then do this entire problem and then have no idea where you went wrong, right? That is just the most frustrating thing that a student can be in, right? So for the first few problems, do that, right? Be like, okay, I have Excel here. I know what the answer is. I need to know that I'm being careful with my computational work, all right? All right, so please do that. The next column, right, it's going to be X minus X bar, all right? So I am doing 13,185 minus 14,051.1, 1,800 minus 14,051.1, all right? And we're going to go ahead and write out those answers, right? So for this first one here, right, this is 13,185. This is negative 866.1, right? I'll go ahead and do the first few, and then I'm going to autofill the other ones. 14,051.1. This gives me 3948.9. All right, so I'll go ahead and we're going to go ahead and do that real quick, and I'll be right back. Okay, and here we go, all right? I went ahead and got all those values. And last but not least, and I know this is a long problem, all right? You're probably going to get one of these very long ones on the exam. The other ones aren't going to be, so you probably get 2 of these actually. Getting 2 of these, with other ones being much smaller values, right? For like I said, like I mentioned, information omitted, right? this next, before I go to the next column, right? I'm not sure if I had mentioned it, but let's just say I give you everything and I give you sum of squares, right? Oh yeah, I did mention it, right? So you get your variance by using sum of squares over n minus 1, and then you take the square root. Oh, I did mention that, I'm sorry. It's just really, really important. I want you all to fully understand, right? So, not fully understand, but please be fully prepared, right? X minus x bar squared, all right? Whew. So I'm gonna go ahead and square this last column, right? Meaning I am dealing with negative 86.1 squared, right? Right, this here ends up giving me 750,129.21. And I'm going to do it with 3948.9 squared, right? Let's go ahead and do that. And while I'm here, I'll go ahead and do that, right? 39. I get 1559381.21. Yeah, I'll definitely won't give you something with very large values like this one. All right, I'll go ahead and definitely give you something much more smaller to deal with. But in terms of length, right? In terms of n values, you can expect something like this, like n of 10 or something, right? But definitely small values. So we're gonna go ahead and compute all that, and we'll be right back. Right, and since we were actually talking about Excel, all right, let's go ahead and apply what I had mentioned, right? So I'm pretty much going to do everything I did right now just in Excel, right? So here's my X column, right? I wanted to find my X bar, right? So I'll say X bar. My X bar was just the average, or in other words, the sum of these values, right? Divided by n, right? Oh, wait, what am I doing? The sum of those values, sum of all these values divided by n, not divided by 2, divided by n, and my n was, what was mine? 11, right? So there we go. The other one was x minus x bar, right? So this here would be equals, I want to choose this value, minus always this value, always this x bar. And we said we're gonna write these dollar signs before the letter and before the number, right, of that cell. That's going to lock that value in, right? And I want that copied all the way down. And then I'm going to do x minus x bar squared, right? Meaning I'm going to get this value and square it, right? And I'm going to do that all the way down. All right, and if you noticed, yeah, these are the correct values, right? That's what I had here, all right? And one thing we had mentioned is once you get all these values, right? Once you get that squared value, once you get all these values here filled in, you're gonna sum up that entire column. And that is also known as your sum of squares value, right? That's known as your SS, your sum of squares, right? Meaning, right, so if I were to sum this up, let's sum all of this here. Escape. Ooh, there you go. All right, we want to do sum of this entire section here. What's going on? So I'm doing this sum of, and it gives me this large value, right? So my sum of squares is, let's go ahead and add commas to this, right? 30, what was that? We'll go ahead and round up to the nearest whole. We'll do one decimal, right? So that is 34590. $50291. what I said, you may want to go ahead and have this handy. All right. Meaning we mentioned, right? So I got my sum of squares, meaning, right, if I need my, okay, let's go ahead and fill in my data here. My mu, right, is 15,500. I do not know my standard deviation, right? My alpha is 0.05. Let's go ahead and find my variance first, right? My variance is equal to sum of squares over n minus 1, right? My sum of squares is that over 11. All right, is that over 11? Go ahead and do this in Excel. All right, so this value here divided by 11. Oh no, it's not 11. It is not 11. I almost did a whoopsie there. My degrees of freedom is 10, right? So be very careful. Here divided by 10, right? It gives me that value right there. All right. Nice. So meaning my variance is this value here, right? Variance is 3,459. 050.29. And you know how to get the standard deviation from this, right? You know how to get the standard deviation from that. You take the square root, right? Meaning I'm going to went ahead and take the square root of this. Right, so this here, standard dev, that is variance, right? So my standard deviation, right, is rounding up 1859.9. 1859.9, 1859.9, 1859. All right, so let's just say you wanted to check your work, right? I understand, right? You may want to check all of this, right? Then use the code, right, for standard dev. Your standard deviation of this entire thing here, right? Hey, there we go. It's the same thing, right? So, right, the wonderful thing about Excel is you can always check your work, all right? And again, I'm not going to give you these values in the millions, right? It's going to be in the hundreds, right? Maybe like low thousands, right? Like 1,000, 2,000, but not that insanely large, right? There's a lot of room for error there. But it is going to be on your homework, right? Okay, so what were we doing, right? What were we doing? In other words, we were just doing pre-work, 1859.9, 1859.9. Woo, right? Now we can go ahead and get started, all right? Now we can go ahead and get started with our problem. So yeah, this some of these require a lot of pre-work, especially when it's just your raw data given to you, right? So my A, right? State the hypotheses and identify the claims. Is there seven? My random samples teaching stipend differs from 15,000. What was our mental note? Right. Oh yes, right. So alternate hypothesis was different, right? The level to conclude that the average stipend differs from 15,000, right? So it does not include 15,500. Meaning my null hypothesis has to be 15,500. So this is going to be a two-tail test. All right. A two-tail test. All right. Meaning t-crit is what I'm going to go ahead and find next. These degrees of freedom is n minus 1, which is 10, at alpha equals 0.05 for a 2. For a two-tail test. Where's my t-table? All right. 10 at 0.05, 10 at 0.05. Right, 10 at 0.05 for two-tailed 0.05, 10. Right here, right? Two-tailed 0.05 with a and degrees of freedom of 2. Yes, there we go. 2.228, right? 2.228. So it's a two-tailed test, so it's going to be plus or minus 2.228, right? So you have two values. Go ahead and zoom out for all of you. And then I mean need it again, right? This is the golden formula there. This is the wonderful golden formula there. All right, so meaning I'm going to go ahead and draw this. Yes, you need to draw it for your exam. This is negative 2.228. This is 2.228. All right, now we're going to go ahead and find T observed, right? T observed. So T observed is going to be, right? Of course, and anytime you may pause the video, right? And this, you end up finding out that this value gives me negative 2.584, right? Negative 2.584. Negative 2.584. And you want to know, is the observed value within the critical region? It is, right? For this example, it's on the left side, right? It's on the left toe. It is, right? So yes, therefore, reject hypotheses, all right? So meaning you're going to answer yes to the question, right? Yes to the question, right? So there is enough evidence to support that, right? To support the claim that the mean stipend for teaching assistants in economics differs from 15,500, all right? There is enough evidence to suggest. So that is all I have for today, all right? Like I mentioned before, right? You may have to do one of these tests, right? Let's go ahead and see if I can bring up an example. Okay, so for an example would be like this, all right? So you're giving a mean value, right? Let's just say I give you 50, right? I give you a mu, right, for the 24.1. Your standard deviation is not there, all right? Your n value is given, all right? So let's just say that's 10, all right? But I also told you that the sum of squares is, I don't know, let's see, something like, your sum of squares is something like 78, all right? Something like 78, all right? And I'm asking you to run and I'll probably ask, right, hey, run a two-tailed test or run a one-tailed test, all right? Right, run a one-tailed test or a two-tailed test. So I know if I tell you to do a two-tailed test, all right? If it's a two-tailed, right? Your no hypotheses, all right? This would be mu cannot equal 24.1. Your mu can equal 24.1, all right? Meaning, hey, you really need the sample distribution, right? You need the samples, I'm sorry, sample standard deviation, all right? So, hey, they gave me SS, they gave me sum of squares, but oh, the instructor, right, the professor said I can use this to find variance, right? All right, so S squared would be 78 over 10 minus 1, right, which is 78 over 9, right? 78 over 9, it gives me 8.67. 8.67. And I know how to find S. I take the square root of that, 8.67, all right? And the square root of 8.67, right, would give me 2.94. Right, so boom, right? So in other words, that would be the pre-work you would have to do, right? So please be on the lookout for those. Yeah, that is all I have for you all today. Thank you very much for your time. And like I mentioned before, right, it's nice to have Excel up, right? So you definitely want to go ahead and use that as a tool, right? As an education tool to be sure you're on the right path, right? So please let me know if you have any questions or concerns. Thank you very much for your time, and I hope you enjoy the rest of your day. Thank you.